Now let's roll, huh? Okay. So last time we had talked about modeling quadratic functions, and we had homeworks 11 regarding that. Does anybody have questions from homeworks 10 or 11, really? I mean, those were the last homework checks. We'll start there. And again, you can say that aloud or you can type it into the chat. Either is fine. Probably the chat's a little bit easier, so if there's a couple of people with questions, they kind of queue up for me so I know where I'm going next, and I don't have to try to remember because it's 7:50 on a wintry, snowy morning. Happy December to everybody. It makes it a little easier to kind of keep track of things. Okay. Homework 11. And number 1. Okay. So the first thing that we're going to want to do on any of these modeling problems is to figure out which form of a quadratic function we want to write. So we have to look at the information that's provided. Here we're given a vertex and a point. So we want to use vertex form, which is y equals a times x minus h squared plus k. And the nice thing here about vertex form, or to write our final answer, then we need to figure out a value for a value for h, and a value for k. And the nice thing about vertex form is the vertex here tells us the values for h and k right away. So we're like 2/3 of the way done immediately. We still have to find a. To find a, we're going to use this other point as an x and y. So if we plug all of that stuff in, so -3 is going to go in for y, a is what we're looking for, 0 is going in for x, -2 is going in for h, and 5 is going in for k, I can now solve for a directly. So to solve for a, 0 minus a -2 is +2, and +2 squared is 4. So we really have 4a. And then to solve for a, we'll just subtract 5 to the other side, and then divide by 4. So now we have our values for a, h, and k. So all we have to do now is put those into the formula. And there's our final answer. Joe, are you happy with what we did there?
Yep, thank you.
Yeah, no problem. No problem. Are there any other takers on questions? Happy to do some more. All right, well, I'm not going to give you guys a choice because judging from your homeworks, I was not real pleased with your guys' attempts at 5 and 6 here. Oh, we do have one for number 2 on homework 11. So it's like the exact same situation, right? Because we have a vertex and a point. So we have an h is 3 and our k is -4. And to find our a, we're just going to plug this in to our same vertex form. So -1 in for y. A is what we're still looking for. +1 in for x. 3 in for h, and negative 4 in for k. So 1 minus 3 is negative 2, and negative 2 squared is positive 4. And then to solve for a, we'll add over the 4, and then divide by 4. So there's our values for a, h, and k. So just plugging those in. There's our final answer for that. And then I saw we had another one for homework 10 sneak in there when I wasn't paying attention. Megan, are you happy with what I did there?
Yes, sorry.
That's okay. You take your time. It's not, we're not in a big rush or anything. And I changed the page on you before I asked that question, so oops, forgot one of the pages there for homework 10, it looks like. Raylan, we're looking at, you say, number 7, which is this one. Okay, so here we're looking to graph. So to graph this, I need to find the vertex. So the way we find the vertex varies depending on the form that our equation is. So if I look at this equation, this is vertex form. So I know the vertex is just h comma k. So that would be 3, 5. In this case, remember the h is always the opposite sign of whatever it appears in the equation. So I'll make my 5-point xy table here. So we'll put the vertex in the middle, and then I'm just going to pick some x's, 2 x's that are less than the x-coordinate for the vertex, and then 2 x's that are bigger than the x-coordinate for the vertex. And then to find their corresponding y-coordinate, I'm going to just take turns and plug each of these x's in. So if I start with 1, I'll plug that in to my equation for x. So 1 minus 3 is negative 2. Negative 2 squared is positive 4, but then I have to make it negative, so it becomes negative 4. And plus 5 is 1. And then we'll do the same thing with the 2. 2 minus 3 is negative 1. Negative 1 squared is positive 1, but then we have to make it negative, so we have negative 1. And then plus 5 is 4. And because I've picked my x's so that they're kind of symmetric to the vertex, notice that all the x's are 1 unit apart. I know these other y-coordinates are going to be kind of symmetric also, so I can just fill those in. You could all alternatively just continue plugging them in like I had done for the previous 2 also, if you weren't sure about whether it would be okay to do that or not. So now I just need to plot my points. Something like that. Little messy, but you get the drift. It's hard to draw a neat graph on OneNote.
Thank you so much.
Of course. Of course. So I do want to do one of these 5 or 6 from homework 11. When I checked your guys's, these were not very complete. So I wanted to make sure that we take a moment and do one of these just to remind you guys what to do on this. So here we're just given 3 points. And if I look at these 3 points, there's not like 2 x-intercepts given. And I can tell that because the y-coordinates need to be 0 for it to be an x-intercept. So none of these are x-intercepts. And I don't know if any of them are a vertex or not. So I can't use vertex form. and I can't use intercept form. So I really have to write this as a standard form problem. So the standard form is y equals ax squared plus bx plus c. And for me to answer this, I need to figure out values for a, b, and c. Now those values of a, b, and c don't directly relate to the values of these 3 points. So I can't get anything for free, like I could on those previous ones, where I could get 2/3 of the problem just by just from the points that were given. So what I'm going to do is I'm going to build a system of 3 equations, because I can't solve for a, b, or c in a problem if I have 3 variables in it with just 1 equation. I need 3 equations to build a system with. So I'm going to take each one of these points as a separate xy and plug each of these 3 points in for the x's and y's. So when I plug in -5, 6, 6 goes in for y, -5 goes in for x, and then we'll do the same thing with the next point. And the same thing with the last point. So this is my system. And the way I showed you guys the fast way to solve this system was using a matrix. But to use that matrix, I have to write this system in a certain way. So I'm going to go ahead and evaluate like all of these things. And then I'm going to move the equal sign to the right-hand side instead of the left-hand side. So -5 squared is +25. And then we have -5b. And I'm going to put a 1c. I'm going to write the 1 in front of the c that is there. We usually just don't write it. And I'm going to make sure I write these 1s in, because when I turn this into a matrix, I'm going to be glad that I have those 1s there, because I need the coefficients, and it's sometimes easy to forget what we put in for a coefficient if I don't have the 1 there. Okay, so this is what my system looks like. So the matrix that I'm going to write, the first row is 25, -5, 1, 6, and 1, -1, 1, 2, and then 0, 0, 1, 6. And that matrix I'm going to use the command rref on, and then the calculator will take care of all of the work in solving that matrix, and it'll give me the values for a, b, and c. I just have to then write those in as my final answer. So let's show you guys how to plug this back into our calculator, because we had done this before. So to enter a matrix into our calculator, I need to access the matrix menu. So I'm going to press second, and then the x to the -1 button to open the matrix menu. To type in a matrix, I need to go to the Edit tab. So I'm going to use the arrows to move over to the Edit tab. And I'm going to select one of these matrices. It doesn't matter which one. Mine have stuff here because I already have stuff entered in, but I'm just going to type over it, so it's not a big deal. I'm just going to use matrix A. The 3x4 tells you the rows and columns, so the rows is always first and the columns is always second. The matrix that we wrote has 3 rows, 1 row for each of the equations. It has 4 columns, 1 column for the A coefficients, 1 column for the B coefficients, 1 column for the C coefficient, and 1 column for what it equals. So I don't need to change that. So it needs to be 3x4, but I didn't have to change it because that's the matrix I chose that it was already a 3x4. And now I'm just going to edit these. So I'm going to type in 25 and then just press enter. So I'm just going to type in exactly what I've written down on my paper. I'm just pressing enter to move to the next spot. Okay. So all I've done is I've typed in to this matrix exactly what I have written down on my paper. So now that I've done that, I'm going to exit out of here by pressing second and then the mode button. And now I need to retrieve that command rref. So to get that command, I need to go back to the matrix menu. So I'm going to press second and the x to the negative 1 button. And this time I'm going to move over to the Math tab. And from the Math tab, I'm going to scroll down until I see the rref command. Make sure you pick the rref command and not the ref command. There is a difference. You need the one with 2 R's. Once you've located it, go ahead and press enter, and that'll paste it to the main screen. And now we just need to go back and retrieve that matrix that we just wrote. So we'll go back to the matrix menu, second, and x to the negative 1. And then from the Names tab, I'm going to select this matrix A that I just edited, close my parenthesis, and press enter. So what this output was is this, but the part that I really care about is just this last column. Because this last column is just giving my values for my A, B, and C. So my answer would be 1x squared plus 5x plus 6. And I'm all done. So I wrote down a lot there because I wanted to make sure that it was easy for you guys to follow, like what I typed into my calculator and how I got the system and all of that sort of thing. But like you really don't have to, for example, write down both of these two systems. Like you could just write down one or the other, would have been fine as far as showing work goes. And then this is going in your calculator. I would like to see that as well as the your final answer configured. So really just, you know, use some stuff to write down, but none of it was not a lot of computation on your part. The calculator did most of the heavy lifting for us there. Okay.
Mr. Kulik?
Yes.
Oh, sorry.
Go ahead.
So since like I know Thursday we have a test I looked on PowerSchool, can you go over how to solve or how to figure out when it's in standard form or vertex form, or like what form the equation's in?
Sure.
Thank you.
Sure. So the 3 forms that we've talked about are standard form, which is something that looks like this. So then there's vertex form, which is something that looks like this. And then there's intercept form, which is something that looks like, oops, we used P's and Q's, I think. Looks like this. So the key here is you have an x squared and you have an x, right? Now, some situations you could have like a 0x there and you could treat it as you see only an x squared, but you should specifically see like an x squared somewhere, right? So that's your big cue that you're looking at a standard form equation, is if you physically see an x squared. Not something that could turn into an x squared, but x squared is explicitly written down for you. So for vertex form, what you're looking for is like something squared. So that something squared could be like a set of parentheses squared, or it could be just an x squared. You can think of something, for example, x squared plus 5, you can think of as vertex form, or standard form. And then this one is just like you're looking at two sets of parentheses. Joe, is this what is this what you're looking for?
Yep, that was exactly it. Thank you.
Yeah, no problem. So Joe had jumped or stepped on it a little bit here, but that was the modeling was the last topic for this chapter. So we do have our chapter test coming up, and I've scheduled that for Thursday this week. In the content library, you're going to see a chapter for review. The format for this chapter for review is going to be the same format as the test. It'll be less questions on the test, but the same types of questions. So like from, like a section, instead of having like 3 questions, you might have 2, or instead of having 5 questions, you might have 4 or 5 or 3. You know what I mean? But it'll be the same kinds of questions. And I've gone ahead and put in a key for the review as well, with some work shown, not a tons of work shown, but hopefully enough to where you can kind of like sort your way through it if you weren't for sure exactly what I did. So that's what we'll do with the rest of our time here today. Is I'm going to let you guys work on the review unless there's other questions, and I'm happy to answer more, whether they're specific things or just kind of general stuff. I'm happy to spend a little bit more time and ask if you guys have more questions. Okay. If you don't, I'm going to dismiss you guys. Before you go, please type bye into the chat for attendance purposes. And you can spend the rest of your time here working on the review. If you have questions about things, feel free to email me in the interim. And have a good day. Stay warm. Build a snowman or something. And if you have individual stuff, I'll stick around if you wanted to ask anything. So have a good day, guys. You're welcome.